Justin Bailey. I don't know whether Noel did introduce you, but I'll give a very brief introduction. Justin's a vet with Novartis Animal Health. He's a graduate from UQ, and he has a PhD in parasitology from Armidale Uni, and he's the Novartis Technical Services Manager for Australia and New Zealand. So thanks very much, Justin. It's over to you.
Okay, thank you, Noel and Tony, and thank you very much to everyone for dialing in. Hopefully everyone can hear me, but I guess you can put your hands up if I'm not coming through clearly enough. Look, the first thing, I guess, for those of you who aren't familiar with Novartis, we're one of the few remaining R&D companies, in other words, research and development, who are sort of actively going out and looking for new molecules to bring to market, as opposed to waiting for them to come off patent and copying. So I guess what I mean by that is that we're trying to actively, or proactively, I guess I should say, find solutions for pressing issues, and clearly drench resistance has been that for us for a long time in Australia. So moving on, hopefully the slide transitions are working okay. I just wanted to do a brief, I guess, review of where we're at and where we've come from in terms of drenching. So I apologise if sometimes anthelmintic comes up, simply means drench. And first of all, I guess this slide here is some data from Meat and Livestock Australia. It was published in 2006, based on 2005 data, and it was looking at the highest cost diseases of livestock around Australia, and specifically this table here is looking at sheep, and in terms of their cost nationally per annum. So you can see that internal parasites of sheep are far and away the most important disease, not only of sheep but of livestock in Australia. So far more costly than any cattle disease. A couple of points I guess I'd make about this slide. Firstly, when you look at fly strike and lice, next most important diseases of sheep, they're very visible when you think about it. You can see struck sheep, you can see lousy sheep, so it's front of mind. But very often you won't see the damage that internal parasites, that worms are causing sheep, right until it gets to quite a severe stage. So in the case of Queensland specifically, where we're more concerned with Barber's poleworm, by the point we actually see bottle jaw or a tail in the mob, we're still sheep dropping dead. We've been suffering a lot of damage before that, and that's very clearly demonstrated when you look at those bars. The grey portion of the bars is the cost in terms of lost production, and the orange portion of the bars is actually the cost in terms of control. So that means treatments, labour in terms of mustering, monitoring, that sort of thing. So only about 13% of the cost of worms to the sheep industry, so to farmers, is associated with the cost of control. Now this is based on 2005 data, like I said. So back then it was about $70 for a first cross ewe, about $2.90 carcass weight for lambs. So we're in a completely different ballpark now in terms of value of our product. So despite the decline in flock numbers, I'd suggest that it's a far more costly disease today than it was then, and also that a greater proportion is actually lost production. This highlights, this next slide, I guess, is a way of trying to highlight the fact that by the time you see the clinical effects, so in other words, the visible signs of worm infection, your farming system has been suffering reduced productivity for a significant period of time. So if we look at the top of that sort of figure there, you can see we're going from no worm exposure at all right through to heavy worm exposure. And with no worms, of course, there's no effect. And heavy worm burdens, of course, with Barber's pole, we're going to see significant numbers of dead sheep. I guess the point is, in terms of what we see, we either see clinical effects or we don't. So the green portion there is what we don't see, and the clinical effects are when we start seeing sheep dying, bottle jaw, maybe scouring if it's scour worms. So the key point, I guess, I'm trying to make is when you look at the grey below, that the loss actually starts occurring from the minute that worms are infected. So they're a very costly disease, but we don't always see it. And Holmes and Sackett, fairly well-known Australian agricultural benchmarkers, have estimated that you can lose up to 20%, 15 to 20% differences in live weight of sheep that you're not visibly going to notice, however good a manager you are, simply because they're covered in wool. So unless you're actually laying on hands, it's very difficult to detect the cost of worms to sheep. And of course, many producers will drench sheep, send them back out the paddock, and just assume or perhaps even hope that their drench has worked. And they're not really going to see that or work that out until, the cost of production is extremely significant. And I guess I'd suggest not many businesses could cop a 20% loss in productivity. So this next slide is, I guess, looking at a timeline for the development of drenches. Some of us might remember the first of the modern drenches, which was the first of the white or the benzimidazole, the BZ class of drenches. So that thiabendazole came out in 1961 and pretty much revolutionised sheep farming, I guess, in areas where worms are prevalent. On this graph, you can see so these are the actives, not the brand names, but any active that is the same colour is from the same class or family. And what that means is it works in exactly the same way at killing worms. So you can see there's a lot of white drenches came out in the 70s, all work in exactly the same way as the first white drench did. So these are just the broad spectrum drench actives. Levamisole clear drench was 68, I think, in Australia. And the last broad spectrum drench class to be introduced was the DMLs, or the macrocyclic lactones, of which ivermectin was the first. I think it was about 82 globally, and we got it in 88 in Australia. And then, of course, moxidectin and avermectin came along in the mid-90s. So I guess the point I'd make about those is when drench resistance occurs to one active within a family, it will eventually occur to all the others because they work in exactly the same way at killing worms. I guess what we've seen with ivermectin is that it's the least potent of the MLs, and of course it was the first introduced, so we saw resistance in it first. Avermectin is the next most potent, and moxidectin the most potent of the three MLs. But of course there's resistance to all of those actives now to a greater or lesser degree, and this is where we're at now. So monopantal is the name of the first active from the new drench family, and it's the name of the active that's actually in Zolvix. So I guess what that timeline says to me is two things. Firstly, that we can't expect a whole heap of actives to come along. It's been a long time between drinks. And secondly, we need to seriously consider how we best use this new drench because of that, because we're just not getting new drenches popping up every day. This is the best estimate we can make of the state of drench resistance around Australia. So the bars are representing the percentage of Australian farms which we would expect to have resistance to the given actives that are down the left-hand side of that graph there. So all broad-spectrum drenches with the exception of chrysanthal, and this is based on worm monitoring data from the main parasitological labs around Australia. So this would be where drench resistance exists in at least one worm species, and in many cases it will be multiple, or even and also to a number of the different actives as well. So if we look at the top one, we can see the white drenches. We'd expect greater than 90% of Australian farms, there'd be one worm species at least that would be resistant to them. Then we go down to the clear drenches, greater than 80%. Now, Maxine will probably talk about this in a bit, but in the case of my part of the world, the New England and southern Queensland, we're probably at the top end of that. We're about as severe as resistance gets in Australia, and that's about as severe as it gets in the world. You can see when you combine whites and clears together, so the BZ-Lev, what's happening is that survivors of one drench active are hopefully being killed by the other, and you can see that that's the case. So we're trying to get efficacy up above 95%, so greater than 95% of the worms are actually killed, which is, once you drop below that, that's the definition of resistance. And by combining two actives together, we see there's fewer farms, although it's still significant, that actually have resistance. Chrysanthal resistance is obviously severe. When we look at the MLs, we're looking at ivermectin because it's the least potent of the three ML actives that we have for sheep, and therefore it's the most sensitive indicator of ML resistance. And southern Queensland, maybe 70%, and my part of the world, somewhere greater than 80% of farms couldn't expect full efficacy from an ivermectin treatment. So a couple of quick points I'd make about drench resistance. Firstly, that it's an individual farm thing. So if you've got a neighbour who's done a drench resistance test, that's fantastic. There's no relationship to what the situation is going to be on your farm. They need to be done every sort of 2 to 3 years ideally, because the situation changes. So every farm's different. Unfortunately, very few people do drench resistance tests, which is a shame, because otherwise you're simply guessing or hoping that your drench will work. And until resistance is very severe, you're actually not going to visibly see those failures. I guess the other point I'd make is that drench labels are historical data in many ways, because it represents what the claim set of those products were at the time of their release. And in many cases it was 20 years ago or more, so resistance will have potentially changed the efficacy of many products. I think that's enough on that. So if we just get on to Zolvix now, the points that I guess I'd like to cover off on today, it's a completely new class, so I'd just like to emphasise that. It means it has a unique mode of action, so it works in a completely different way to all existing products. Has great efficacy, so we're getting 99.9% efficacy in a large number of trials conducted around the world. I'll go into that in a bit more detail, but certainly from my perspective as a parasitologist, if we've waited so long for a new drench, I think we probably would have settled for anything we could have got registered, but it's great to see it up around those extremely high levels. It's got a very nice safety profile for reasons which I'll explain, and they've also thought through very carefully about how best to deliver this new product. So rather than just introducing a new drench, they've thought through the whole process of drenching and how they can make it perhaps a little bit easier for farmers. So the actual drench class is the aminoacetonitrile derivatives. I promise I won't mention that name again. I think what we'll find is it's going to be known as the AAD, or more likely the orange drench class. And you can see the chemical structure on the right-hand side there, which of monopantyl, the first active, which means nothing to me, I have to say. I'm no chemist. I just make the point about monopantyl, the antyl suffix you can see on the end there. Some of you will be familiar that some drenches, like praziquantel, the tapeworm drench active, clisanthyl, end in antyl. It doesn't mean they're the same drench family. We're given the active name by the World Health Organization, and antyl simply means it's an anthelmintic or drench. So all new actives will have the suffix antyl. Zolvix is a low volume product, so it's 1 ml per 10 kilogram of body weight that you're delivering. So that's nice in a number of ways. I guess it's less weight on your back when you're drenching. It's less refilling required. But perhaps more importantly, with low volume products, there's less risk of what's known as gut trigger or rumen bypass, which is where drench actually misses the rumen and actually goes through into the abomasum or fourth stomach. And what that means is that there's less time for absorption of the drug, and you can potentially underdose. So rumen bypass is more likely with higher volume products, and more likely when products are incorrectly administered, so over the tip of the tongue as opposed to over the back. And Zolvix is clearly, you can see there, orange-coloured solution, self-lubricating. It flows through the gun very nicely. And that's what the packs are going to look like. In terms of why it's a new drench class, because it's got this unique mode of action, it works, it kills worms, but firstly it paralyses them, so it prevents nerve impulses from getting through to the muscles. And you can just sort of see there a schematic where the little orange molecule binds onto what we call a receptor or the target. So the target side of the active, which is highlighted in red there, the molecule binds to it and interferes with the function of that particular target or receptor. Now, the only reason that's important is because the particular receptors which monopantyl and Zolvix work on are not targeted by any of the older drench classes, so none of them work on this particular receptor. And secondly, that receptor is only present in nematodes, which is the name for roundworms. So it's not present in mammals, which is why we believe it has such a nice safety profile. So there we go. I think I've probably just covered on that. The fact that The receptor that monopantal works on is different to all other drenches currently on the market. It means that resistance to existing drenches is irrelevant to the efficacy of Zolvix. It will work at full efficacy regardless of the resistance status of worms on your farm, and also that it has an impressive safety profile. Just to support that, I guess, you can see here this is Barber's poleworm, Homunculus contortus. Now, this is a multi-resistant strain of Barber's poleworm from a commercial farm in New South Wales. That's what some people might call a superworm. And we can see we've got different drench actives across the bottom and the efficacy. So how well these drenches killed this worm when sheep infected with this worm were treated. Just remembering we're aiming for 95% efficacy. So you can see 3% efficacy from a white-clear combination. In other words, 97% of the worms were left behind. A triple was not much better. Ivermectin might as well have given those sheep a drink of water. Probably could have got the same result. Moxidectin was a bit over a quarter of the worms killed. Closantel, better again. And then when we look at I'll find the right thing to click, when we treated sheep infected with this worm with Zolvix against the immature worms and against the adults there, you can see greater than 99.9% efficacy. Now, you can only get that clearly if the drug works in a completely different way to all these other older actives. So when we're talking efficacy, this is what the label is going to look like, or it does look like on Zolvix. There's a lot of Latin names there as well as the common names. I just put that up there to demonstrate that it is a broad spectrum drench, covers off on a large number and all the economically important roundworms of sheep. It doesn't do tapeworm or liver fluke because they're not roundworms, so it's very specific. The target is only present in roundworms. If we drill down a little bit deeper, I guess, to the most important worms that are outlined here, certainly for Queensland, there might be some non-Queenslanders here, I guess. So the most important worms Australia-wide are Barber's poleworm, small brown stomach worm, and the two types of black scale worm. In terms of Queensland, we're looking particularly at the highlighted one, so mainly Barber's poleworm, but also this type of black scale worm on occasions. We've got adult efficacy against adult worms and immature worms in these two columns. The numbers in brackets simply indicate the number of sheep that were infected with those worms when they were treated, and you can see here greater than 99.9% efficacy against all those important worm species. I should emphasise that this is the gold standard study, so we're not doing it based on egg counts. This is what we call slaughter studies, where we're actually sacrificing the sheep and actually counting the worms that are left behind in their guts, if indeed any were left behind. The other point I'd just quickly make is you see down the bottom here, we've done something that I think is fairly unusual, and that is that all this work's been published in peer-reviewed journals. So all the information's out there for industry experts and anyone who's interested to actually look at and review and make up their own mind about this product in this drench class. You know, you don't have to listen to me or take my word for it, which I think is a kind of a good way of going. We need to confirm that efficacy out in the field, so on commercial farms. So around Australia, we looked at 12 commercial farms. You can see there a whole range of geographic regions. We treated different classes and ages of sheep as well as different breeds. And we also did around the world, at least 41 farms we looked at around the world. And across all of them, we were achieving 99.9% efficacy against whatever worms were present on those commercial farms at the time of treatment. Now, many of those farms also had resistance and indeed, on a number of occasions, multiple resistant worms present. So I guess that's really nice confirmation of what we could expect, can expect, every farmer here in Australia can expect when they use this product. So look, this is just a simple way of running through what that means, so what that high degree of efficacy means to farmers. I apologise that there'd normally be an animation which the webinar technology didn't agree with, I think. But if we look at where there's a drench to which there's resistance, so in other words less than 90% efficacy, in the animation within the gut of this sheep you'd see red worms and blue worms being susceptible to any given drench, one of the older drench classes, and redworms, which are resistant. So if you treat those sheep and the susceptible or blue worms are killed, the redworms survive. Now, I guess what that means, to my very simple way of thinking, is firstly you're losing production in the sheep that have been treated with a less than fully effective drench. There's worms left behind, and worms cost you money. The second thing is that they're passing out, reproducing and passing eggs onto pasture. And of course, that means if conditions are right, there's the potential for higher pasture contamination, which will result in a cost to your sheep further down the track. And finally, continued use of an ineffective drench, it just continues to decline in efficacy till it gets worse and worse. If you compare that to a drench to which we know there is no resistance, so in the case of Zolvix, we know it'll be fully effective regardless. At the end of treatment, we would expect that there wouldn't be worms left behind. So what we're doing is we're maximising production of the treated sheep, we're reducing pasture contamination and prolonging the drench life of the drench that you've used beforehand, because instead of those resistant survivors still being there, we're taking them out of the system. This is just the only example that I'm aware of where this has actually been measured in terms of cost to productivity, so less than fully effective drenches. A study conducted by a guy called Brown Beasy in Western Australia in the mid-90s, and he compared a fully effective, so 100% effective drench, with drenches to which there was already resistance, so 85% effective and 65% effective. That was pretty typical in the region at the time. And for each of those levels of efficacy in terms of the drenches, he had merino weaners that were treated 3 times over a 12-month period. So that was November, February, and the following August. And at the end of that, they assessed what that meant to the producer on that farm. So comparing the 100% effective drench with the 65% effective drench, you can see there's 6 kilograms more body weight accrued to the sheep treated with 100% effective drench, better condition scores, almost half a kilogram more wool. They had 3 times less light use scour and had 3.5 times less deaths. Now, I just put a few current numbers around that. So I plugged in $4.60 in terms of dollars for the kilogram carcass weight. I put in a 46% dressing percentage and 7.90 cents for greasy wool per kilogram. And if I can bring it up, that was the difference in terms of dollars per head between a fully effective drench and a 65% effective drench across the year. Now, I'm not saying that's going to be the case in every example, on every farm, but that's what would have occurred on this farm in current values. Now, that's not even looking at scouring or death. Now, I recognise also that will be largely small brown stomach worms, which will be different to what we'd see in Queensland. However, of course, the mortalities proportionally would be much higher in Queensland. In this particular study, also, what they saw was that 65% effective drench the next year was 38% effective. So, rattling on, in terms of the safety profile, conducted a lot of studies in ewes and rams with repeated treatments at higher doses, weren't able to detect any adverse effects at all. Same was done in the offspring of those treated ewes and rams, and also in lambs treated with 10 times the recommended maximum recommended dose of Zolvix with no ill effects whatsoever. So it makes it a very nice treatment to use. We call it a tenfold safety margin because we know that lambs are the most susceptible to overdosing. Same reason in terms of operator safety. Mammals don't have the receptor that the active works on. Meat withhold 14 days. Environmental safety, no concerns with dung beetles, earthworms, etc., because they're not roundworms and they don't have the target that the drug works on. If we look at the export slaughter interval, it's the only thing that I can think of that I'd like to change about Zolvix, and it will change in due course. It's 115 days. I guess the points I'd make about that, firstly, are that it's trade-related, so it's totally unrelated to product safety. In fact, Australia is the only country in the world that has ESIs, or export slaughter intervals. Every other country in the world you can export sheep meat at the same time frame that you can consume it domestically. The second point I'd make about that is that it's only going to exclude the use of Zolvix on farms that are producing prime lambs that are going to be slaughtered through an export abattoir within 115 days of weaning, which I guess would be your first opportunity to treat them. So even on farms where that is the case, I'd strongly advocate that farmers found an opportunity to use the product in their other classes of stock, so their ewes, replacements, and rams. A few ideas just quickly on where to use Zolvix. So the strong advice from Novartis will be to integrate it into your drenching program now. Don't wait, and that's certainly the message we're hearing very strongly from advisors and parasitologists right around Australia. Strongly support what we call IPM, so Integrated Parasite Management Principles, which I think Maxine will talk a bit more about. So we're talking about regular worm monitoring. In other words, knowing whether you need to treat or not. I know on extensive properties it's often a lot easier just to treat when the sheep are in the yards. It's pretty easy to get worm monitoring samples. You can do it out in the paddocks. There's no point in giving sheep a drench if they don't need it, and conversely, if they do need it, the cost of productivity is going to be a lot more than the cost of just getting them into the yards and treating them. So strongly advocate that. Drench resistance testing, of course, is a given. You wouldn't guess with other things on your farm, so why would you guess with a drench? And all the other principles we know, good pasture management, nutrition, having fit animals, and potentially the use of genetics, so sheep that are more resistant to worms. I'll put in a plug here for Worm Boss. Fantastic website. If you're haven't had a look at it, I'd strongly suggest you do, and you can subscribe to it and get a very good newsletter as well, which will keep you up to speed with what's happening. And Maxine contributes to that, of course. A few just basic principles. So if you don't know your drench resistance status, and the vast majority of farmers, 90 to 95% don't, haven't got a current FECRT, there's only one drench that you can use in complete confidence, knowing that it will be fully effective, because we have seen resistance to all other actives and combinations of actives around Australia. If you do know your drench resistance status, that's fantastic. And what we're suggesting is within season rotation of Zolvix with other anthelmintic drenches that you know are fully effective will maintain the efficacy of all the drenches you use within that program and maximise your productivity. So I guess for producers, to my mind, producers who have a range of fully effective options left, you're the ones who'll get the most benefit from Zolvix, because you've actually got something to protect. You're not actually boxed into a corner where you have to use the new anthelmintic, but you will get the benefit by using it. So that's what we'll be saying. Every flock, every year. Now, that doesn't mean we're saying every time you pull out a drench gun, use Zolvix. That would be irresponsible for any drench. I'd suggest what we are saying is find the most important time in the year where you really need to have a fully effective drench and use Zolvix then, and then rotate away to other drenches, so with different classes within the year. This is a flip or a reverse, if you like, of the slide I put up earlier. So earlier I showed the percentage of farms in Australia where we'd expect to see drench resistance. If we swap that around, this is showing in the dark grey the percentage of farms where we'd expect actives to be fully effective. So you can see it's kind of scary if you're using these products without knowing your drench resistance status. And of course, part of the reason I put that up is to demonstrate if you use monopantal, which is Zolvix, that's the percentage of farms. 100% of farms, we know it'll be fully effective right now. So we're saying use Zolvix as part of a strategic within-season rotation. How that might look, weaning treatment. So in terms of, we talk about the 3 Ps, productivity, preservation and protection. So productivity, we want to get the best results we can in performance out of our ewes and lambs. So weaning, both for ewes and lambs, if you can do it according to label recommendations, I believe it's an excellent fit. Partly because it's full efficacy that we know we'll get, but also because of its nice safety profile in young stock. If anyone's dialed in from southern regions, winter rainfall regions, the first summer drench. So it's a strategic treatment. You're giving it for a long-term benefit. Absolutely critical that they be as close to 100% effective as possible to get the full benefit from them. So producers may choose to go with a pre-lambing treatment. In terms of preservation, so it's protecting other drenches that you still have that are fully effective. Again, I really like the weaning treatment for lambs and ewes. We know that pre-lambing treatments may be highly selective for resistance, and what we don't want to do is take resistant worms that have either survived in treated ewes from pre-lambing or been picked up off pasture by the lambs and spread them around the rest of the farm. So in many ways, use of Zolvix at weaning is like a quarantine drench within your farm. You're not spreading resistant worms around. And tail cutter or exit drench, for those of you familiar with that, industry best practice is that following the use of any long-acting drench, that you should rotate away to a short-acting drench and one from a completely different class. Because producers who need to use long-acting drenches obviously value having the opportunity to do that. So it's really important that you protect the actives involved by removing any resistant survivors at the end of the life of that drench. And the last one, protection, of course, is quarantine. So what we don't know is the resistant status of sheep we buy in onto our farm, whether it be from sale yards or from breeders and studs. So there is only one product. Existing resistance can only be to all the existing broad-spectrum actives. There is only one product we know that will be fully effective regardless. So some advisors will undoubtedly say still to use a combination of products, and that's great. I don't disagree with that, but certainly if you're only using one product, it should be Zolvix. And if you're using a number of drenches, then Zolvix, again, should be one of those. And look, I think that's where we end up with every flock every year.
Okay. If you have any questions, fire away.
I just had it's Hannah Field here. I just had a question regarding efficacy of Zolvix in the larval stages.
So the immature stages in the sheep, yeah. Is that the question?
Of nematode iris in particular.
Yep. So for the immature stage of nematode iris spathager, we don't have a claim on the label because you have to reach 95% efficacy to get a claim, and our data for Zolvix was about 93, a bit over 93% efficacious, so just missed out on getting a claim for it, but it will kill 93%. And so I guess the proof's in the pudding, and when we did those field studies in Australia, 9 of the 12 sites had nematode iris, and we were removing, as you saw there, 99.9% of all comers. So, because we got to remember that nematode iris is not very fecund; it puts out very few eggs. So,
Noel Dempsey here. I've got a question for Justin. Justin, what's the recommended retail or approximate cost of Zolvix?
Yeah, good question, Noel. And the short answer is I don't know. I know there is no recommended retail price for it. So it'll be whatever the resellers decide they want it to be. It will certainly be. It will cost more than existing short-acting products on the market, as you'd expect. But I think the best advice I could give is for people who are interested, just give your preferred reseller a call or ring around the resellers, and you'll have an accurate price within 5 minutes.
Lloyd Dunlop here with another question for Justin. Justin, do you require a new drench gun for this, and can you use your old drench gun?
You can, absolutely, Lloyd, you can use your old drench gun, and if you wish to do that, you just want to make sure you rinse out the Zolvix after use, which I guess is industry best practice anyway. So you'd want to use warm soapy water, and allow the gun to dry before reusing it with another product. Perhaps all the usual things about a bit of vegetable oil or whatever on your O-rings and seals. But yeah, absolutely, it works. It flows very nicely through guns. It's obviously the Zolvix gun's been designed especially for it, the OptiLine drencher. But yeah, fine through other guns.
Second question, you might have answered this with your answer on nematode iris, but I'm just wondering whether there's Are you seeking registration for other species of worms, such as the flatworms? You mentioned the roundworms. What about flatworms?
No, we're not, because it doesn't. The target that the drug works on is only present in the roundworms. So your bulbous pole, etc., etc. It's not present in tapeworms, and it's not present in fluke. So we don't have efficacy against those types of worms.
Is there any thoughts to register the product for use in cattle?
Yep, another good question, and certainly our R&D people will be looking at, I would suggest, in pretty much every species you care to think of. I'm not privy to that information, but very confident they'll be looking at it in other species. Brought out initially in sheep purely because it was the area of greatest need, as opposed to the biggest market, of course, with cattle being much more significant.
Trevor Risman here, Justin. Wondering, with the ESI said 115 days, that's likely to change, you think?
Absolutely, because it's a new product. Maximum residue limits haven't been established for it, so there's an organisation called Codex that is involved in doing that. So that's in train, but that can take some time. So once because of the safety of the product, once maximum residue limits are established, we expect it will be drastically reduced, shall we say, to much closer to the meat withhold. But at the present, for countries that don't have the product and possibly import some of our meat, they have a nil detectable residues requirement, so countries like Russia and China. So the ESI reflects the limit of detection, as opposed to obviously being related to any sort of safety factor.